Welcome to my channel, Better Through Tech. I'm Drew, and I'm revealing my face for the first time. I've had a few friends and a couple family members suggest that maybe I should show my mug to the world to make some of my videos feel a little more personable to everybody. So here I am. This is my corner. This is where I make all my magic happen for the projects that you've seen possibly in other videos, but in this one, we're going to be talking or addressing this LED matrix. This is going to be a 2-row, 3-column setup, so it's going to have 6 segments in it. It's a good bit bigger than most other projects that are out there right now. I wanted something bigger. That way I could see it from a distance. I wanted something that I could put up back here in the corner and be able to see anywhere from my living room or my kitchen. This is going to be using a seed Zao, I think is how it is. My apologies if I'm not enunciating that correctly. Not really sure how I should be enunciating it. But it is a ESP32 C3 microcontroller with Wi-Fi connectivity. So yes, we will be working with Wi-Fi to connect this up, to be pulling information. So that way, this doesn't have to be locked at your desk with your computer in order to work. As long as you can give it a power signal, you should be able to set this up anywhere once you're done programming it. So if you want it in another room, or you wanted to put it out in the garage, or if you're maybe doing this for an office space and wanted something to have in your office specifically, or out in the bullpen, I guess, if you will. As long as the information has been programmed, you can put this thing anywhere. So we will be going over the code on how to pull the APIs, most specifically from YouTube, so that way we can get viewer and sub counts on here, so at a glance you can see the information. But we will be pulling the time and date as well as weather forecasts to put on here too, so you can get a full feed, I guess, if you want to put it that way, across here. So it'll just constantly be rotating a feed of all that information through here, so at any one given time you can glance up and get whatever information you need for the day. So other than the programming, we will also be going over the CAD work that it took to put this frame together, the 3D printing, and the prep work to get this done. And then we will get the assembly. So just in this video alone, we will only be concentrating on this. In the next video, we will be building the frame and putting that together to have this be able to be put into a safe container, a box, so that way it will be protected from the elements, potentially anything else, dropping on it, falling on it. Don't have to worry about the LEDs getting scratched or anything like that. So over the course of the next 50 to 60 some odd minutes, stay tuned and we'll show you how to build this. Okay, again, welcome to Better Through Tech. This is going to be a good, long, complicated build. Well, not that complicated. There's a lot of steps to it. This is the Zao microcontroller I got. It's the very first time I've ever using this controller, so this is was a bit of an experience for me. Wasn't bad, actually. I love playing with new microcontrollers. It's just this one has so much more when it comes to capabilities than an Arduino Uno, right? Even an Arduino Omega, like, this thing has got a lot to it. And there is the 2.4 gigahertz antenna, or that we will be using later. Let me get this package open here. This is the microcontroller that we're going to be using. It is got an extremely small form factor, which was one of the main reasons why I picked it for this project. It's probably not really a whole lot bigger than the circumference of my thumbnail. I mean, it is a little bit, but not by much. It is actually quite small. But being that it is an ESP32, the -3 subseries, it is actually quite powerful as far as programming is concerned. Next, we have got a couple of things to install. We are going to first start off with the board manager. We are going to type in ESP32 to show the corresponding programs to run these boards. I have installed both of them. You may need to install both of them, but specifically for this project, we're just going to be looking at the expressive systems here, which is the second one. Before you hit install, just make sure that it is up to date before you do it. Just by clicking that down button and making sure you got the latest date. Go ahead and install that. Next, we are going to do a quick look up. We're going to go into tools, boards, then you'll find the ESP32, and then you'll be able to see every combination of ESP32 board available in the market right now in this file. So you should have no problems finding what board you're using. Next, we are going to click on the libraries. We got two files specifically that we need to look up. We have the MD Max 72XX. That is going to be one of two that we're going to look up. The other one is at the bottom, the MD Parlo Ola. I don't know why I did one right after the other, but it's just kind of the way I did the pre-recording, I guess. But you'll want to make sure to get both of those installed. Again, make sure they're completely up to date before you install them. Once you do that, it's super easy to get everything. You can do examples, and you can pull up the libraries. Here, we just can scroll down through our library section. We can actually find them. See, there's MD, the Max 72 right there, and the Parola right there, which will give you all the examples that you need to be able to play with this if you don't really feel like doing a lot of programming right now, or you just want to get spun up on how everything works. This next section, though, I just wanted to run a quick test because I want to be able to make sure that I can get all of my matrices working, making sure they're working properly, right? I had a few of them I need to test, and I had a couple other ones I kind of wanted to mix in with my new ones, so I just wanted to make sure that everything worked properly. So that's why I pulled up the test here. It does say Parola with underscore WH here. This will need to be changed. Everything that gets used, pretty much anything you can find off of Amazon, is going to be the FC16 series LED matrices. So if you pull these up, you're going to need to make sure to switch that over, or else the code's not going to work. And each one of the segments has 4 matrices in it. So since we're only going to be running one right now, we're going to be testing one unit at a time. Each unit obviously has 4 sections to it, so we're going to hit 4 on there. Now, with the boards here, it is important to note there is a direction that these have to be wired in. And it's a little confusing because when we start installing everything, it will feel kind of backwards. Because facing the board, everything reads from the right to the left. So when you're hooking this stuff up, you will connect it to the right. And then all the information will flow from there to the left side. Now, here I am trying to get everything hooked up and connected to run the tests and make sure everything is working with my used matrices. And then once everything's uploaded and running, you can tell that it has a preset layout for graphics to make it work. So after doing a couple of those, I think I just kind of decided just to go with all new matrices. And there should be 6 of them in this bag, so I have a little bit of a fun little reveal here. But I have... Okay, so there's 3 in one bag, 3 in the other bag. But these will be the matrices that we will be using specifically to build this matrix board. Yeah, cool little tip there for you. If you don't have anything to really open up the static bags, a pair of fingernail clippers works great. It gets that little slit in there, you can just rip it right open, which is really nice. So this will come with a bunch of wires, and it comes with a whole bunch of pins. We are not going to be using any of this stuff that comes in the bags. We are actually going to be removing the pins that are already soldered, and we're not going to use any of this stuff. So if you plan on building this project exactly the way I'm building it, you will be able to save all this stuff later for some other project, because you're never going to need it for this. Okay, so here is all 6 of the sections that we're going to be using. So we have a little bit of desoldering ahead of us to get all these pins removed, but I'm playing around with them a little bit to kind of show about the different layouts that we could be using. But this is exactly how we're going to be setting it up. This will be the layout right here. So, you'll have to excuse me trying to reach around the camera here. In order to remove these things, you always want to kind of give them a little bit of wiggle with some pull. You don't want to be overly forceful with them. These pins are very easy to bend. And it's not too much of a deal to bend them back, but if you're not aware that you did it, it can make putting them back kind of a little rather challenging, especially with the way we're planning on laying them out. But I then removed all the ones that I needed to solder or desolder. So I pulled them all up to get ready for the desoldering tool. This awesome tool right here, speak of the devil, is my desoldering tool. I bought it specifically for this project. I had been meaning to want to get it for a while now, but doing this project just didn't seem like a lot of fun without having that in my hands to do all this work. It took a little bit. There was a little bit of a learning curve to be able to figure out how to use it properly, but by the end of doing this, I was actually really efficient or proficient in doing so. It's really nice. You just get the solder hot, and it gets liquid. You push the button, and it creates like a vacuum, and it sucks up all of the solder, right? And as long as you create a good enough connection to create that vacuum, it'll completely clear out the pin. And I really don't think I had much of a problem removing the pins after I had done this. Some of them you needed a little bit of a wiggle, but nothing more than that, which I thought was really good, considering that those the barrels on the circuit board themselves are actually really easy to break, and they're really easy to disconnect from the circuit board themselves. So I was really impressed that all it took was a little bit of a wiggle to remove them. It's not the only way to do this, but for me it was the easiest way. You could also grab your soldering iron and lay it across all the pins at the same time and just add a whole bunch of solder to it to get all the pins hot at the same time, and then you can wiggle and pull it out real fast. It's a little bit of a process. You gotta kind of work on a good fluid movement when you're trying to do all that, because it just takes a split second and that stuff solidifies again, and then you have to work on the process all over again. So there's other options to doing it besides this. If you don't have this tool, it's not a big deal. This just makes it a good bit easier, and I was very much glad that I had bought it. So as soon as you get the whole process down, as you can see right here, it just took a little bit of a wiggle, and those pins just came right out. I was thoroughly impressed with how well this worked, because it made short work out of something that easily could have taken an hour or more to do, and it increasingly put me in a situation where I could have very easily messed up the circuit boards with how easy it is to ruin the solder ports on those circuit boards. But after I have gotten all of them done, the next bit of magic is to take place. So, the difference between okay work and great work is the details, right? So what we're going to do here is we're actually going to set up our own jumper pins between one set of 4 and the second set of 4. Well, so we got to do 2 rows of 3. So there's 5 on each side, so what, 5, 10. So we needed to make 20 of these little jumpers. And it's not a very hard process. I happen to have several of these little LED legs laying around, and for the life of me, I could not focus this thing, so I apologize. But what this is just an extra leg off of an LED. So whenever you solder them, you have all that extra leg sticking out the back side of the circuit board, just snip them off, right? Maybe just throw them away, whatever. So I saved a few of them and used those actually to make the jumpers. I have a pair of mini needle nose pliers. Sorry, I cannot talk right now. And I had one of my extra circuit board tools and just kind of bent them in place. The short leg right there actually takes a little bit of force to bend into place. You'd be surprised at how well that will dig into your skin with how short it is. For some odd reason, there's just like a lot of resistance with how short it is. So that's why I was using that tool to help bend it. The other side, I had a lot of leverage because of how long it was. It was really super easy just to bend it in place. But after doing so, I would just let go of it with the needle nose and just snip it to make it so that way the legs were even on both sides. and just wash, rinse, and repeat 19 more times, and those were all the jumpers that I needed to solder everything together. I will have to say though that if you do decide to go this process, be very careful. If you have anything even remotely magnetic or slightly sticky, these things are so small and so light that it's very easy to lose them. So it is very, very easy to lose what you're doing. Okay, the next and oh so important part is making sure you get all the measurements down properly. This, just a spare piece of paper, doesn't take much, and in my case, I like to be as accurate as possible. In most cases, you probably should strive to do so. So I got my micrometers out, and I spent probably a good 15 minutes making sure that everything that I did was as accurate as possible to my drawing and my measurements were to the physical layout. After that, it was time to hit the CAD and start putting this together. It is important to note that these are just the test pieces. These are not the pieces that were used for the final build. So I just want to make that clear, because I know that what's on the back of the matrix and what I'm building is not exactly accurate. Some of it is, but these were just test pieces to make sure my fitments, the fitment and all the alignment was right. These are the legs that will actually help. Well, they were the legs, but those you saw there were the legs. Those will actually put back pressure on the box to help lock the circuit board up to the front face of the acrylic to actually keep it in place, so that way it doesn't fall out of the ideal spot where it needs to sit. Then we have a quick mock-up or layout on the CAD, or from the CAD onto the 3D printer, and it's time to let the actual magic start taking place. Again, I also want to note this is just one of the test pieces. That's not the actual piece, because genius me, I forgot to record the actual print. So I apologize, but you'll just have to suffice with me printing some of the mock-up pieces to test for alignment on here. I also want to point out too, it's important to note this, because I know this doesn't exactly not line up properly. These first couple pieces that I design are more just for test fitment to make sure all my alignment is correctly, because anybody who does any serious level of 3D printing knows that things can shrink after it cools, right? So most of this right here was more or less set up so that way I can make sure that all my alignment, all the hole mounts, everything was proper. Once I had that all figured out, then I started getting a little more into the actual layout and actual design and the spacing for everything to make sure it was laid out properly. So once it is done though, this is how it came out. That big old structure kind of looked like a weird ramp, right? And cracking it off took a few seconds actually. There's some pointy stuff on the backside of that thing I was not anticipating, and it kind of made me hesitate a little bit trying to pull that off there. But as you no doubtedly are aware, that these things usually can often come out with a bit of a mess on them. So I spent a few minutes here with my blade and cleaning up any extra, any build-up or any webbing, spider webbing, I guess. Because not all the prints, actually come out as perfect as you'd like them to all the time. So most of them do and will need some cleanup. But after I had spent the time smoothing everything out, a really good tip for this is to use a small torch, and it will very much help with the cleanup process of getting rid of all the webbing or the spider webbing, all the little strands that kind of hang out there. You just give it a quick little blast with that thing and it'll clean it up really fast, as you'll see I'll do here in a second. So I made this back bridge right here, so that way I had a very specific spot to mount the microcontroller, the ESP32, and the antenna. I could have mounted it anywhere on the backside, but I wanted to make sure it had a very specific spot for it to sit. As you can tell, I just pointed out right there that I forgot to make notches at the end to solder the wires from one segment to the other. Totally forgot I had to do that, so I had to do some custom work on cutting those out. But I did fix it in the CAD later. So here's a mock-up of what it all looks like when it's sitting on top of that backbone, I guess. I'm not really sure what would be the proper name for it. But so there it is, all lined up. Actually, even with it not being actually screwed into it, it held everything quite sturdily. It didn't really go anywhere with it. It held it in place real nicely. But yeah, so there it is. I'm just kind of pointing out a basic example of the wires running, and then I forgot to make the notches there again. I completely forgot about that stuff. Again, like I said, I did make corrections on that for future prints, so that way it's so anybody who wants to use this, it's already been fixed and corrected. So here, again, make sure to keep track of the direction of the input and output. Yeah, make sure that everything is pointing in the same direction. So the clip that I showed you earlier, I pointed it out how it said in and out. You're going to want to make sure that all those are pointing in the same direction. One really quick thing to note, since I almost forgot about this, the hardware that we're using is an M3x12. So if you're wondering about that, that's what I'm using. Also, when you're assembling this, make sure everything stays loose, so that way you have room to move everything around before you tighten it all down. The number one spot to hook up is going to be the bottom right side. That will be the main input for the first unit, and then it'll feed completely over to the very left, and then you're going to make a jumper from the bottom left to the top right, and then it'll just repeat the process over again. I know it's kind of a little weird and a little confusing. It kind of gets me a little bit. It kind of tripped me up a couple times trying to do this too, when trying to put it together. But make sure that everything, all the arrows, are pointing from the right to the left, since that's the way all the data will feed. Otherwise, you're going to have all sorts of problems, and it's not going to, probably might not catch on or understand what is really the problem. But after you get everything lined up, we're going to use those cool little jumpers that we made and get them put in place. Here I am trying to put a couple more in place. Some of them, like I said, were giving me some problems. I think my mini needle nose pliers might be a little magnetic, because every time I tried to let go, they would come back out with my needle nose pliers after I tried to pull them away. So that's why I'm using that tool right there to help push them in place. But after that, I laid them all 20 of them out, and then the fun begins by actually linking them all together, right? We soldered every single one of those together. Take your time here. The plastic is right underneath that, so if you hold them for a bit too long, I mean, it's not the end of the world, but you will burn into the plastic if you made your jumpers just a tad too long. So yeah, so just a little bit of process going through and soldering all of these. You will want to make sure that you test them to make sure they don't wiggle, because if they're wiggle, that means they're not very good, don't have a very good connection, and that will cause issues. Trust me, these LED matrices are quite finicky with bad connections, and it'll show. And if you take any shortcuts or half-ass it in any way, it will show through on the display. So I recommend carefully and thoroughly going through and soldering every pin and making sure that that spot soaks up the solder, so that gives you a good solid connection. It probably wouldn't even hurt to possibly even get a voltmeter and test for continuity to make sure that they're all connected and feeding through properly. If you do go the route of using the voltmeter test for continuity, it is important to note that data in and the data out lines will not work for testing continuity. That line actually goes up into the chip, and it does something in the chip, and it will not pass the signal through. But the clock, the CS, the ground, and the voltage, you should be able to test for continuity anywhere throughout the length of the circuit board. So that's a good way to make sure if it is connected or not. But again, if you do try to do that, data in, the D in, and the D out will not work like that. Okay, so here I am laying out where everything's going to sit and how I'm going to be setting everything up. And as you can tell, how I grabbed that bottom right corner and I flipped it over, which then became the top side. It's very important, like I mentioned before, and I'm going to keep on stressing this because there's a lot of stuff going on here, and it's really easy to get things mixed up and not placed properly. So I got to really stress it. Always make sure to keep track of what you're doing. I bought a 5-strand wire pack for this project to make sure that I can keep all the same wires connected to the same pins throughout the entirety of this build. So there's no crossovers in colors, there's no mix up of the wires, and I try to keep everything as straight and as simple as possible because this is already kind of getting a little more complicated than it needs to be, right? So if you need to set anything up, make sure to, if you have to make sure to maybe get a piece of paper and a pencil and write down what color is connected to what pin. Whether it's the power, the SDK, SLK, SCK, I think I just said those wrong, but you get the idea. Make sure you have them, make sure the color makes sense to you, and make sure to write it down, because you're going to have to jump these things around, and you're going to have to double check things, and you're going to have to compare it against your code to make sure everything is connected properly and sending the right signals. Because it can be a little tricky, especially if you're not super used to doing this kind of work. This can trip you up, and it can trip you up really easily, really quickly, and it will cause glitches and interference on the matrix face, and you will see it. It's only a matter of time. So the more you take your time, the more you do this work, the better you make the connections and the solders, the better everything is going to be in the long run. And the longer you will be able to run this matrix without having any errors or glitches coming across the front face of it. I will have to note, you don't have to do it this way. I think I was just being a little stubborn and trying to prove to myself that I could actually do this. I do recommend feeding one wire in and soldering it, then the next wire and soldering it. For some odd reason, I just had this idea that I could put all 5 wires in there at the same time and just
just go from one to the next and go solder, 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 and just be done. It can be done, but getting it set up can be a bit of a pain in the butt. So if you're not super good at soldering, or if that's a process you're still learning, I highly recommend to maybe split the wires apart a little more to give you a little more wiggle room, and just put one wire in and solder it at a time. Because if you try to do what I did, there's a good chance you might end up getting frustrated. I know I was getting a tad annoyed when I was trying to do this, because I was like, come on, I know I can do it. I know I can do it. And I did do it, but it took probably a few more minutes than it should have. And I made the process a little more difficult than it needed to be. So once you get all the alignment set up, this is what it's going to look like. Again, I have it flipped upside down, so it doesn't quite look right, but once flipped up right side up, that bottom right corner is going to be the side that comes from the microcontroller, and then it will zigzag across to the other side. So mind you, remember, this is upside down, so when you're looking at it right side up, that's how it's going to work. From lower right to lower left, and then a jumper from lower left to upper right. Make sure to get that done, make sure to do that right, because otherwise this is not going to make sense. But now let's look into the microcontroller and we will examine how we're going to use this. Now let's look up the microcontroller and figure out how exactly we're going to wire this thing up, so that way we know what we're doing and why we're doing it. So we're going to go to the website, Seed. Right? We're going to use Seed with 3 E's. Don't forget that, or else this is not going to work. And it's going to be the Studio ZAO ESP32S3. And Seed Studios actually has a wiki specifically for this microcontroller, so it gives you all the information that you're going to need. Now, it's important to note that we're not using the ZAO library to run this, so we're going to be using digital pins 5, 6, and 7, but it's going to be physical pins 6, 7, and 8, because we're actually going to be using one of the libraries at the top. And let me look it up really quick, because I seem to have forgotten it for some weird reason. But we are going to be using a library at the very top called the ESP32C3 Dev Module. So we're going to be using the actual physical pins to run this. So it's important to note that. So if you try to run this later and you do use the ZAO library and the Dev library don't use the same pins. But after everything is set up, this is about what it's going to look like. Now, we have everything set up on the 5, 6, and 7 pins, which is right up here in the front. You'll have to excuse the blurriness. As you can tell, right up there up front is 5, 6, and 7. I will point those out once we get to the programming part of it, so you can see what you're doing. Now, this is something I had to do as well. Because I was having a lot of grounding issues. I had to make a jumper at the very end, from the bottom left to the top left. I was having grounding issues, which was causing the LED matrices to glitch out really bad. So what I did is I used an injector. It's kind of an injector, but I used a jumper to the second row to ground out the very end of the second row, so that way I could stop having glitches. Okay, now that we are in some more familiar territory for me for programming, what we're going to do is we're going to do a little bit of testing to make sure that all of our boards, all the connected boards, work together. So we're going to go into examples and we're going to find the height 2. That's specifically the library that we're going to be using for this layout. The Perorla double height version 2 is what we're going to be using. That's how we're going to test to make sure everything's working. Again, since this is going to be a test run, actually, like I said, should do this with all of them. Make sure to change this over to make sure it says FC16, because that's just the way that the libraries were created. We don't use those ones specifically here, especially a good majority of the ones that are bought off of Amazon. If they are stated otherwise, I do believe they should be stated as such. But it's a pretty safe bet if you buy them on Amazon and some places like that. It's just going to be the FC16, so always make sure to switch that over. Once you get that switched over, go ahead and plug it in. Plug in your microcontroller, and we're going to do some testing to make sure that it works. And now we got something reading here. I just realized I think I might have played a couple of these clippets out of sequence, so I apologize. Once we get to the main part of the code, I'll show you what pins are connected to what wires, because I realized I didn't do it here for the test. So I apologize. There's going to have to be some backtracking on this. Okay, I see what I got going on here. Pins 13, 11, and 10. This is on the Arduino. So, okay, so that's the reason why I didn't go over it on here, because I was doing this test on the Arduino to make sure that it was running properly before I completely hooked up the ESP32. So it's not completely hooked up and run yet. I'm trying to find the proper number zones and zone size to make sure everything is properly accounted for on here. This took me a few minutes. For the life of me, I don't know what it was. I could not figure out what combination of what went where in order to get this to work. I don't know why it took me so long, because after I figured it out, it was just kind of like palm and face. Like, really? Like, I should have known better. I did. I really should have known better. Because I do believe that it ends up being 2 and 12. I think is what the overall number layout for this was supposed to be. And yeah, I felt kind of dumb after I had come to that realization that that's what it needed to be in order to get that to work. Oh, and before I completely forget, and this will probably happen a little later in the video to show you, but when you make sure to make the leads, the power leads that connect to your microcontroller, I split them off and did a shrink tubing on them and ran the 5 volts, one set of 5 volts directly to the microcontroller and the other set of 5 volts directly to power the matrix. So I just wired them off and had one lead go one place and their lead go to the other. I didn't really get much of a chance to point that out. I think you'll see it here in a little bit. So that way there's only one 5-volt lead, but it goes to 2 different places. So that way you don't have to do a bunch of over soldering directly at the microcontroller to try to get it to power the matrix or power through the microcontroller to the matrix. And I think mostly that was to just avoid overpowering the microcontroller. So that way it had its own feed to do it. But once I got the size figured out, sorry, to go back to what I'm doing here. Once I got the size figured out, I let it run its test format to make sure that everything on there was working properly, which thankfully right off the bat it was. I didn't have to do a lot of messing around from this point on. Once I got the test running, pretty much everything just ran, which I was super happy about. And for some of you, if you want to wrap it up here, by all means, if you just want to use this as a letterboard to say Happy New Year's, 4th of July, Happy Halloween, Thanksgiving, Merry Christmas, here it is right here. You just got to put some wording in right there, and you could just use this as a letterboard. And if that's all you wanted to do, congratulations, you're finished, right? And on some of my earlier versions, that's exactly what I did. Some of my earlier versions of this, when I was doing some testing, that's exactly what I did. I did one for, I did it for New Year's, I did it for Halloween, I did it for Christmas. But yeah, at this point, you literally can just get it to say whatever you want, if you didn't want to do the whole API workout. And I forgot to do the brackets on that. Good job. It gets the point across though. You can play with it any way you would like. But stepping forward, this is the main code that runs the entire system. And stated as earlier, the pins 6, 7, and 8 I was talking about, if you look down to lines 29 through 31, those are the pins specifically that you'll be connecting to. Yeah, you can see that 6, I know this order is kind of a little backwards, but the CS pin goes to pin 6, the data goes to pin 7, and the CLK, or clock, goes to pin 8. And you gotta remember, since we're using the other library, this is the physical pins, not the digital layout, because the way that they're assigned is different in this library. So one thing to keep in mind. Like I said, I'm not going to get into this too deep because we'll be here forever. I'm going to gloss over a couple of things and point out a couple of things, so that way you can get this working yourself. And it's important to note that this font data header, you have to copy this from the main file, or else this code is not going to work. So what you're going to do is go into Documents, go to Arduino, go to Library, and then you're going to scroll down till you find the Parola, the MD Parola. Once you open that up, you're going to go into Examples. And once you open up Examples, you're going to go into the Parola Double Height version 2. And see that font data? You're going to right-click that and hit Copy, because you're going to need that. So once you have copied that, go to where you're saving this file. I have mine saved in a different hard drive because I kind of like have separation and safety just in case my main hard drive crashes. But then you're going to want to paste it in the same folder where you're saving this main code at. So that way it can directly reference that in the code. So again, one more time, make sure it is in the same file that it's being saved in, or else this is not going to work. So stepping on from there, this is the time zone that I'm using. I'm using Pacific Standard Time. If you're anywhere else in the country or anywhere else in the world, you're going to make sure to change that. This section here is for your Wi-Fi. Well, the top two are for your Wi-Fi and your password. The bottom two is your API key and your channel. I will show you how to find those in a minute. And it's not very hard to find them, but it is a bit of a step-by-step process. From there, let's go ahead and scroll down a little bit. There is a good lot to look at. I will make this completely available for you. If you do want to use this code, I will make it completely available for free on my GitHub, and I will have the 3D files available for you on Cults 3D. But that section right there that I just highlighted will be where all your API information is being referenced. This section right here is where I'm getting my weather information at. It's from the National Weather Services. This station ID, you're going to need to replace that specifically. Get rid of the curvy brackets when you replace it, by the way. But you'll need to find the station closest to you, and then it'll automatically feed weather reports from the closest station from you to your matrix. This section right here does all the printing, and it just gets printed out as one huge string. And you can change the spacing if you want to get it to read different. I kind of like the way that it reads now. This section is for the brightness control. So when it's sunny outside, it'll get more intense. If it's dark in the house, it'll dim down. So I wanted this to be something that could run all the time. And it's not going to be too dim, not going to be too bright. It is something that will be able to be adjusted on the go, which I thought was really nice. So here is how we're going to get the API up and going. It is important to note that you have to have a Google email in order to make this work. If you do not have a Google email, this is not going to be too easy to do. But so how you get to this spot here is going to be console, console.cloud.google.com is how you'll get to this site here. But this right here says channel API. I do believe it says new project up there since yours will be empty. Once you get in there, you will click on the new project. I need to speed up a little bit here. But once you're in there, you're going to click on new project so you can get a new system set up. Go ahead and give it a name to whatever you want. As you can see here, I got mine blurred out because it has sensitive information that I don't want to be sharing, so I apologize. But you're going to start, click on new project, you're going to give it a name. Once you're done doing that, it will take you to a place like this. And yes, I have those blurred out again because that is sensitive information. But it's going to take you to a place like this. You're going to go down to Explore and Enable APIs. You're going to need to click on that, and it's going to take you to this page. From here, you're going to want to click on Enable APIs and Services right there at the top. That's kind of like, yeah, highlighted a little bit. We're going to scroll down till you find YouTube, and we're going to click on YouTube Data API version 3. It's important you click on that. Okay, so mine's already active, so it says Manage, but it's going to ask you to enable it right there. You're definitely going to want to click on that to enable it. And then from here, this gives you pretty much all the information that you're going to ever want or need about when information is being queried. So that way, whenever information is being pulled from your API, it lets you know what it is or how often it's being pulled, and you can see all that information here. And as I scroll down, you can see all the statistics of all that information. But what you're going to want to do is right here on the left, you're going to click on Credentials. There, as you can see, I got my API key set up and going already, but from there you're going to go up to the top there and hit Create Credentials and API Key. You're going to click on that. Once you click on that, it's going to give you a very specific key for your private information. Make sure not to share it. I have mine faded out here or blurred so it's hard to see, but it's going to look something like this, and you're probably going to have a 20 some odd digit key there that you're going to need. You're going to want to copy that because that is your API key that you need to be able to pull your information, right? So that is going to go right here. Your API that we just copied, you're going to paste it right there. Make sure to leave the double quotations, but you're going to paste it right there. Once you're done, go to your YouTube channel and see the side scroll bar here. You're going to hit Settings. You're going to go down to Advanced Settings, and there's your channel ID. Go ahead and copy that as well. This is public information, so it's not that big of a deal if anybody sees it, because this is how people find you anyways. But that will go right here. Again, make sure to leave the double quotes up when you put that information in there, because it's going to read it as a string, so it needs to see that. And then, once you have it done, then this is about what it will look like once it's reading. This is the box that we're going to work on part 2, but there it is sitting inside of there, chilling like a homie, right? Sitting up in there. There is the double leads I was talking about, and there's the LDR resistor that keeps track of the input light to adjust for dimming, right? So if everything is done right, this is about what it's going to look like. I know we haven't gotten to the box yet, but this is the setup. This is going to read your time, your date, your temperature, and your views and subscriptions. So, holy cow, I know that was a huge mouthful, but there is the process. I will show a couple of pictures so that way I can get some more specific views so you guys can see exactly what I did with the wiring, because I know I didn't do a horribly good job of showing that. But I will finish up with a couple of pictures here real quick, and then I will have a closeout for you. But thank you very much for sticking around. So, this will be the conclusion of this video. Again, this only covers just the LED matrix itself. The next video that I will be posting here shortly will be the actual build for the box. And the acrylic that we cut and the tinting of it, all of the setup and the mounting, the whole 9 yards, right? So that way we can actually finish this project. We were already getting a little long in this video as it is anyways, and I really did not want to make it any longer than it already was. But again, thank you for sticking around. Thank you for being patient with me while I'm trying to find my groove, and how things work best for me to hopefully entertain you. It is a little difficult to find where I'm going with this sometimes, and sometimes I feel like I'm just acting like a fool. So again, thank you for your patience. Thank you for watching clear to the end of this video. I very much appreciate it, and I look forward to seeing you in the next one.